Hello everyone, welcome back to another video on my YouTube channel. Today we are discussing another problem called valid parentheses, and this is another problem in line 75 list of problems. Let's go through the problem. We are given a string S containing the characters round brackets, angular brackets and square brackets, and we have to determine if the input string is valid. And we are also given these conditions to check the validity, that if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So this is valid, and this is invalid, because a rounded bracket should be closed with another rounded bracket. We are also given that the length of the input string is 10 raised to power 4, and the input set is only these three types of brackets. Now, if you look at this example that I have taken here, I have color coded each type of bracket separately. For curly braces, I have used blue color, and for square brackets, I have used this red color, and for the rounded brackets, I have used white color. Now, if you see this carefully, you'll notice that each valid parenthesis expression, which is this complete thing which is valid, has also sub expressions that are valid. So for example, this sub expression is also valid, this is also valid, this is also valid, and this is also valid. Now, if you think about removing these sub expressions, so for example, if I remove this sub expression, the remaining string is still a valid parenthesis. Similarly, I can remove this sub expression. This will still remain valid, and same for this and this complete thing. The string will still remain valid. So that gives me an idea that we can use something like a stack here. So for example, if I have this string, I iterate from left to right, and I have a stack where I keep putting the opening braces here. And what does a brace on the stack mean? It means that it is yet to be processed. Okay. And I keep pushing onto the stack until I find a corresponding closing bracket. So for example, I pushed this, then I pushed this, then I pushed the rounded bracket, and now I found the closing for the rounded bracket. So when I found a closing bracket, I'll check the top. If it is the same, that means I can just pop it off. So just take it out of the stack. And if it was not the same, what does that mean? That means I found an invalid expression. Let me just write down. If it is same, in that case I'll pop. If it is not the same, then I'll say that it is invalid. Okay, so now for rounded bracket I found the replacement, so I'll just pop it off. I'll remove this. Let me just clear this. I remove the rounded bracket. Now I reach here and I check again stack stop, so it is corresponding to this, so I'll pop it off as well. And this is gone from the stack. Now I reach this rounded bracket, which is the opening rounded bracket, so I push it again into the stack, push this again, reach here, pop this off, then I reach here. I found the corresponding opening bracket, so pop this off as well, and at the end I found this curly braces closing bracket. So for this also I found that in the stack it has an opening brace, so I pop it off as well. And what do I need to do at the end of this? I check if my stack is empty. Stack is empty. that means it is a valid expression. But if it is not empty, that means it is invalid. Why would it be invalid? So for example, in this, if I had one more opening braces here, that makes it invalid, and I would still have this left at the end of this and in the stack. So stack should be empty, and whenever I found a closing bracket, it should have the same opening bracket at the top of the stack, otherwise it is invalid. So now let's see how we'll code this problem. Now here I am given a function called isValid, which also has a string type of called s passed to it. Now first of all, I'll create a stack of type char called s. Let's call it st because s is the input string given to us. Now I'll iterate the input string or auto c in s, and for each character in the string, first of all I'll check if stacks if it is a closing bracket or not. So if is closing c, and if it is a closing bracket, in that case, first of all I'll check if the stack is empty or not. If the stack is empty, that means my string is invalid. I'll return false. But if the stack is not empty, in that case I'll check stack top. So if stack.top is equal to opposite of the current character, so that means I found a opening bracket for the closing bracket. In that case I'll just pop. If I don't find it at end and it is any other bracket, then I'll return false. And if I find an opening bracket, I'll just push that onto the stack. And at the end, I just want to check if the stack is empty or not. So return stack.empty. I'll also need to define these opposite functions and the isClosing function. So let's write those quickly. So isClosing will return true whenever I find a closing bracket. So just check if C is a closing bracket of any three types or not. So angular bracket, rounded bracket, and square bracket. And opposite will be another function which will return the opposite of a closing bracket. We'll only be passing a closing bracket to this function. So the cases will only have the closing bracket as the inputs. So quickly write cases for all three closing brackets and return the opposite of those brackets as output. And switch case should also have a default case. So in that case, just return any value. For example, here I'm returning 0. Let's try running it. Okay, so something is wrong. So this opposite function was returning bool. We need to return char. That was the mistake here. Now let's try running it. All three test cases worked. Now let's try submitting it.
As you can see, our solution worked. Hope you liked that. See you in the next video. Till then, happy coding.